My name is Sadashiv Fadnis, and I am a product marketing manager for Rubidium signal generators here at Anritsu. Rubidium implements many interesting features for customers to make their measurements, and I want to talk about one such feature. I'm going to demonstrate a feature that's very useful for nonlinear measurement applications. And the nonlinear measurement applications are typically P1 dB or IP2 or IP3. For these applications, usually you use high power levels in order to test your device because you want to get into that nonlinear zone. You want to get into that saturation zone of your device. So typically the output power level from the signal generators are higher. While the output power levels are higher, you also don't want to go to levels, such high levels that it ends up damaging your device under test. So in order to avoid such situation, Rubidium offers a very useful feature, and I'm going to demonstrate that to you. So what you're seeing on the screen is a Rubidium GUI. I'm controlling a Rubidium signal generator with it. And what you're seeing on the right hand bottom is a display of a power sensor. So I have set up a Rubidium and I've connected Rubidium's output to a Anritsu power sensor. It's an 18 gigahertz USB power sensor, and you're seeing a numerical value of the power that it is measuring. So I've set the output power of Rubidium to minus 12 dBm, and the power sensor is measuring about minus 13.2 dBm. It's about a dB lower than what I have set. I have a bit of a longer cable that connects the power sensor and the Rubidium power output, and that explains this 1 dB loss that you're seeing. Now, the feature that I want to demonstrate is called RF Level Limit state here. Usually in the default state, this RF level limit state is set off, set to 0, or it is in off state. But what this does is it limits the RF output to a specific level that you set here, which is called as the RF level limit. So I'm going to switch this on now, and you can set this to whatever limit you want, maybe plus 5 dBm or maybe 0 dBm or whatever. So let's set this to say 5 dBm output. So assuming that you never want to exceed 5 dBm output level from Rubidium signal generator, irrespective of what you set here. Let's say you forget and you set this output level to 7 dBm or 8 dBm, and you might end up damaging your device at those levels. So you want to avoid that, and once you set this RF level limit and you switch on the limit state, Rubidium signal generator ensures that its output never goes above 5 dBm, even when you set this output level to 7, 8, 9, or 10. So that is a very useful feature for customers who usually test high power amplifiers, and they don't want to get into that zone which permanently damages the device. So let's test that. So remember, we have set the limit to plus 5 dBm, and and now I will increment the output level 1 dB at a time, and you can see the output, the numerical display at the bottom. It is showing you 1 dB increment correspondingly. But as I approach the limit that we have set, which is plus 5 dBm, watch what happens. See, no matter what, output level stays the same. So the output level essentially gets clipped to 5 dBm, right? Now the display, that the output power that you see on the power that gets measured from the power sensor is 3.8 dBm, and that 1 dB is the loss. But if you keep that, if you account for that 1.2 dB, then the output power level is getting clipped to plus 5 dBm. And when I come down, then you again get that same power level variation. So this ensures that once you set that maximum output power level, no matter what you set on this level menu, the output is going to always get clipped to that limit that you have set. Now, one interesting thing is, another useful feature I would say, is that this limit that you have set, this 5 dBm limit, applies only even when you are doing power sweep. So let's do a power sweep and see how that works. Now what I'm going to do is I'm going to take this numerical display off, and I'm going to show you a graphical display so that you can see the sweep happening. And now let's enable a sweep. So let's say we sweep from minus 12 dBm to plus 12 dBm, and see if the output level gets clipped to that plus 5 dBm limit that we have set. So let's switch on the sweep, and let's watch the power sensor display and see what it shows. So as the display rolls, you can see the output power level being incremented at about half a dB step, and then as it approaches 5 dBm level, let's see if the output level gets limited to that or not. We are at 0 dBm now. We are getting closer to 5 dBm level, and the moment the sweep crosses the 5 dBm output, 5 dBm, right, the output is still getting limited to plus 5, and of course the sweep is going back again here. So this is a feature that is very useful when you are doing nonlinear measurements and you don't want to exceed a certain output level. You want to stay always below that so that you don't damage your device.